Hi, this is Gary here. Welcome to the chapter two, or today the topic that we're talking about is the separation techniques. Right, first thing, the overall picture is that what kind of mixture? We are only separating the mixture. Only mixture can be separated. Right, and we need to understand that all the techniques that we're learning here are physical method. They are not chemical. There's no chemical reaction involved. You're not forming new substances. Right, so let's go through these few techniques that we know. So which one to select, there'll be some criteria. So take note of the keywords, right, as we look through. All right, so first thing for filtration, all right, we talk about insoluble, okay, cannot dissolve, right? So they will be as a residue. And of course, whatever that is collected after the filtration is the filtrate, right? The insoluble will be on top. The filter paper, that is your residue. Okay, simple distillation mainly is to get pure water. Later we will see a flow chart. It's easier to s- get an overall picture. So there's a pure water because we call them distilled water, or normally we want to get a liquid, right? But fractional normally is liquid mixture, right? That means miscible liquid. Miscible means they can be soluble into one another. You won't see two layer. You only see one layer. For example, alcohol and water. If you look at alcohol and water, there's no there's no two layers, right? We call this a miscible liquid. We want to pay more attention to simple and fractional distillation. So same thing here, all right. Whether simple or fractional, the few things that we want to focus on is the position of thermometer, right? Because you want to measure the boiling point accurately. Normally, it is. If you look at diagram, normally it will be at the junction where it leads to the condenser. Whether is it fractional or simple, it's the same. Second, it is the water in, water out, right? Similarly, here the water in, water out is very standard. Okay, because we want to make sure that it can ensure effective cooling. So water must always come in from the from from the bottom of the condenser and then come out, right? To make sure that the condenser is fully filled with cold water, so that it is cold enough to have effective cooling. Right? If you go the other way around, then the condenser will not be fully filled. Right. So for fractional distillation is more for liquid mixture, right? Different boiling point. Of course, when you're boiling or you're heating, the temperature will go from low to high. So definitely the lowest boiling point will be separated first. Right. And the main difference is the fractionating column. You can see for yourself the fractionating column. Right. And if you have the soft copy of these notes, okay, you can look through more closely. Basically, this fractionating column allow the separation to be more effective, right? Separation to be more effective. That means without the fractioner, can I still do it? Of course you can, but not as effective as when there is the fractionating column. And there's glass beads. Okay, the glass beads or glass plates are just to condense the vapor that has not reached their boiling point. That means, for example, all right, if I got liquid A at 79 degrees Celsius and B at 100 degrees, for example, there are two liquid, all right, the two different boiling points. Let's say at 79, okay, A will boil. That's for sure. But B will also evaporate because evaporation takes place at all temperature, right? It just depends on how much, how fast. All right. So when the B evaporates, okay, it also become a gas, but it will not be able to pass through the fractionating column because it will condense, right? By the fractionating column. Okay, it will condense and then you'll drip back waiting for its chance. So in this way, they separate the two different mixture by their boiling point more effectively. All right. So simple distillation is more for solid liquid. Right, later we can take a look at the big picture again. Right, so do take note of these two things, the thermometer and the water in, water out. That's very important. All right. And of course, we know about paper chromatography. Okay, paper chromatography, basically there are two common errors or two common safety points, 2 points that we have to take note when we're doing a paper chromatography. First thing, make sure the starting line is above the solvent level. Right, not this way, not this way that where the right where the starting line is below the solvent level. When this happens, means the sample will dissolve into the whole solvent. It touched the water before, it touched the solvent before the chromatography starts. All right, the second thing is it must be drawn in pencil. So take note, all right, it must be above solvent level. It must be drawn in pencil, right? Because pencil that's insoluble, it will not affect the results. Okay, it's all about, it's mainly about the starting line. Of course, there are more precautions, right? But these are the two that's more commonly tested. All right. So the advantage of paper chromatography is that you only need small amount, right? And then it's separated by different solubility. The more soluble will travel a greater distance. So if they're the same distance travel, that means they're the same substances. Okay, okay, I think there's something wrong with this notes a bit here, so I need just to check here. Okay, so same distance travel means they are the same substance. All right, and of course, we separate them is to identify them. That is the main difference between paper chromatography compared to other separation techniques. All right, and how do we interpret pure spot means one, only one spot. Right, it can be checked for purity. The starting line, we were talking about the spot beyond, I mean, after the starting line. Right, if this is the pure. Right, if it's insoluble, it means it never moved, means that it will still remain on the starting line. So what we need to do is we just need to change the solvent. All right. Now, for pure chem students, they learn about, all right, instead of comparing the distance, they talk about RF value. Okay, it's a similar understanding. Later, we'll see the formula for RF. And of course, paper chromatography is not only for colored substance. There are some substances that is invisible to the eyes. We can still separate them, but we will use the locating agent, right, to identify the invisible spot. Basically, it's just like checking for forgery notes, right? You use UV light. So UV light is like the locating agent, help us to see the invisible spot. So that means we carry up the chromatography as per normal. Then at the end of the day, we use locating agent to spray on the chromatogram to make those spots visible. Right? So this is more for the pure chem students. Those you will see that highlighted in red are more for the pure chem students. Right? Then RF value, basically it is the distance traveled by the, if you look at here, basically RF is the distance traveled by the spots over the total distance traveled by the solvent. Right? In chromatography, we always, there will be a point that we stop. Right? We call this a solvent front. Right? We don't let the solvent to travel the whole paper because we might, the some of the soluble sample might overrun with the paper and cannot be captured on the paper. So we allow it to maybe three-quarter of the paper, then we stop. Then there's a total distance. Right. By doing this, we can calculate the R value. So basically, same R value means same substances. It's the same as because the if they're similar substances, they'll travel the same distance away from the starting line. And immiscible means you'll see two layer, right? When you put two liquid, that means they're insoluble. Then we will use this thing called separating funnel. Similarly, it is for the uh, pure chem students. All right. So you will see different layer due to different density and also because they're insoluble. All right. Okay, mainly it's because they're insoluble. Then you will see two different layers. Okay. Right, so the overall picture is this, right? We are separating mixture. So there are different types of mixture. If you look at the big picture, right, there are solid, liquid. So the mention is now, right? If it's insoluble, straight away filtration. If it's soluble, the solid is soluble, then if you want to obtain the solid, you see the same mixture, right? We will use then we'll use evaporation dryness or crystallization. All right, more for getting back the solid. So evaporation and dryness means you heat all the way to dryness, then because the substance is not is stable to heating, then you can do that. If not, normally we choose crystallization. Right, crystallization involves two processes. Okay, one is right we will heat to make it more saturated. Right, more saturated means more concentrated. Then we will allow it to cool to allow the saturated solution to crystallize. That then we'll filter to get back the crystals. So normally we do for crystallization if we do not know the solid is stable to heating or not. But if you want to get back the liquid, then we do the simple distillation. So you can see the difference: solid liquid mixture and liquid liquid. Right, liquid liquid is more for fractional distillation. All right, and then solid liquid then we use If you want to get back the liquid, we use simple distillation. Of course, chromatography is more for identification. Then if it's immiscible, that means not soluble, you got two layer, then we will use a separating funnel. When it comes to solid, all right, depending if there's magnetic, means you got these three metals, then you can use magnetic attraction. Sublimation means solid to gas without going through the liquid phase. So normally, not all solid. Very common one is your iodine, carbon dioxide is your dry ice, any ammonium salt. You see ammonium something sublimation. But what is the most common one? Is what happen if you have one solid that's normally if these two don't work, then technically one will be soluble, one will be insoluble. Right, then there will be three steps. First step is that we will dissolve, right? We add water to dissolve first. Then we filter, right, to remove the insoluble. Then the last one is to I most likely crystallize or evaporation. Okay, we do crystallization to get back the soluble solid. Right. So this is the more common one for okay, we look out for what is a soluble, what is an insoluble. And of course, after separation, we want to look at purity. Okay, purity basically, all right, there are only two ways, fixed melting point, boiling point, or only one spot on the chromatogram. That's the most important, right? Or sometimes we say melts or boils at one temperature. And of course, if you're solid and it's impure, you will melt orange and it will lower the melting point, it will increase the boiling point. But more important thing, pay attention to the purity. Okay, how do we know something is pure? Okay, thank you for paying attention in this chapter. I will see you in the next chapter. Thank you very much.